10. I will go through all of that for your homework. I will go through an example homework today from start to finish. We'll talk about what it means when your code is executed and how that affects writing your code. But I will go through an example homework problem from start to finish today. Okay, it is 11:30. Let's go ahead and get started. So I actually started the stream about 10 minutes ago and then realized I was early. So I will go through some basic stuff today. Before I get to that, just some announcements. Oops, wrong one. Let me get to... Come on. So on UB Learns, I sent out an email. What you guys should be working on right now is finishing up homework 1, and I will go through the steps to do your homework, create your files, submit everything, write your code. I will go through all of those steps. If you noticed, in week 2, I posted a bunch of stuff. So every week, essentially, this is an outline of what you should be doing. So reading chapter 2, notice this is a hyperlink. If you click this, it will take you to your Zybooks. You should also watch the videos before you come to class. So this is, instead of live streaming on Friday, I sent you guys some videos. So here it was 4 videos. They're about 20 minutes. I'm going to try and keep all the content around 20 to 30 minutes. I put them in a playlist, and then you click on this link here, and it takes you to the quiz. So it says the quiz is due at 9 a.m. That's a suggestion. I have sections at 9:10 and at 11:30. Some students aren't going to attend live streaming, although I don't know why you wouldn't want to join our little chat group. And they'll watch things later. I'm really leaving it up to you guys to manage how you want to take in the content. So 9 a.m. is just a suggestion. But if you go in, you'll notice there's really 4 basic questions. It's really just to get you to think about things in a little different way. And then there's a question here that says, what has been challenging thus far? Yes, you can still do the quiz. A lot of people notice you can also take the quiz more than once. You get your answers. Feel free, go back, take it as many times as you want. It's not a time quiz. It's just a comprehension check. It's just to make sure that you watch things and that you understand some stuff and to give me some feedback. So I asked what has been challenging thus far, what would you like more clarification on? That is not necessarily for the videos, that's just in general. What are some things you guys are struggling with that I need to cover more? A lot of you guys talked about function calls and understanding functions. We are going to get to functions on Wednesday. I'm going to talk more about script files today. Okay, so it's just really 4 basic questions this time. It's probably going to be no more than 4 or 6. So just make sure you guys take that. You can take as many times as you want. Just it's to reinforce some concepts. Also, attending lecture. So every week, attending lecture. Here's a hyperlink to the Twitch stream. I give you the notes that I go through in the videos. Today we're talking about writing scripts. Doing homework too. So you'll notice for homework, you have a link to the document, which our homework looks like this week. And then there's also a link to MATLAB Grader. All of you guys should have received an email inviting you to MATLAB Grader this morning. Go find that email if you haven't already. Sign up for MATLAB Grader. Do it right now. Okay, right now. Go sign up. And then now office hours have started. I had some this morning, but here is the link to the document for all the office hours. So notice most hours are covered. You should be able to get help most hours of the day, except for 12, 9, and 5 p.m. On Monday, Wednesday, Thursday, respectively. Every other hour between 9 and 6 is covered. It's all at the same link, so you just click this link, same Zoom, you'll just get whoever is signed up for that slot. I also have the Discord server, people posted on that. I try to respond, help each other. So there's hopefully lots of ways that you guys can get help. Okay, those are the things that you should be working on. Today, I'm going to talk about script files in the context of your homework. So here's your homework document for this week. There's this instruction page. There's a lot here, so let me just highlight some things. So essentially just says you're going to be using MATLAB for your homework. I know you guys are all shocked and surprised. You're going to submit 2 script files, so 2 M files, to the same submission link. Your file should be named like this. So the first thing you guys should do is you should go to wherever you have your files stored. Hopefully it's on some cloud-based service, whether or not it's Google Drive, it's on Box, it's OneDrive, wherever. Go to wherever you have your files, create a new folder. If you haven't already done this, call it EAS 230, whatever you want to call it. Just somewhere where you can keep all of your code together. I'm creating mine in my documents just for illustration purposes. So here I have my folder. I'm going to store all of my files, all of my homework, everything in this folder. Then what you need to do, go open MATLAB. Remember how we talked about your current folder? Your current folder is where all of your script files should be. So use these buttons up here and navigate to where that folder is. So mine was in Documents, EAS 230. Wherever your folder is, if it's on Drive, on Box, on OneDrive, wherever it is, navigate to that, make that your current folder. That should be your habit every single time you start your homework, you work through your homework. Open up MATLAB and navigate to that as your current folder. So then what you need to do is you're going to need to actually write your script files. So you just click New Script. Woohoo! Really simple. Every time you start a new script file, I highly recommend that you insert some comments at the top. So comments, typically I like to insert who the author is, so who's writing this code, insert what the date is. I typically, for this class, I just put spring 2020, because then I know what semester it was. And then also a purpose. Okay. So for the first problem in your homework, you are just calculating mathematical expressions. For your first couple of homeworks, there's really not much comments. A lot of it is just that. As we get a little more complicated, you'll have a little bit more space to put in comments. But for these first couple homeworks, especially this first one, there's really not much more to insert in terms of comments. Okay, so that's where you start. Then you can go ahead and save. So save, and note there's a specific way how you should save your files. So if I go over to here, it says files should be named in the following format: homework x px _ ubit name. And it gives an example. So back in MATLAB, I should save my files as homework 1, problem 1, and then your ubit name, which for me is EH32. It's the first part of your email. Oops. And then .m. Click save. You'll see it show up in your current folder. You'll see it named properly here. Every file has an extension type. So a Word document is .docx, and Excel is .xlsx. Text files are .txt. MATLAB files, our script files, and function files are going to be .m. There are other types of extensions for MATLAB, a .mat file, a .mlx file. Just make sure yours is a .m. Okay, so now I have this file in here, or I have this comments, and now I can start writing my code. Other things to point out, so like I said, you should really name your files with .m. Those ones will be accepted, not ASV, not MLX, just .m. And then it's your responsibility to make sure that your code runs. Now I'm going to give you guys some tips, show you guys how to hopefully read some errors, but make sure your code runs. All of your variables need to be, I will mention MATLAB Online at the end, Sydney. So make sure your variables are named as required. Not all of your variables are required to have certain names, but there are certain variables that you need to have. One thing to mention is don't use the clear command in your code. I know in my week 1 notes, I mentioned that it's best practice to use clear at the top of your code just to make sure you're working with a blank slate. But do not use clear for your homeworks because it won't work in MATLAB Grader and it just won't work for auto grading. CLC is fine. CLC is not an issue because it just clears the command window. Also, make sure you use a semicolon. I will get to that. And then you can use MATLAB Grader, which I will show you guys what that looks like today. Okay, so here we go. We've got our homework. I'm not going to go through that problem, obviously. I have a very similar problem that I'm going to do instead. Ooh, lots of text. Let me just erase all this. I forgot to erase it from this morning. Okay, so your first homework problem looks very similar to this. You're just calculating a bunch of mathematical expressions. So your job for this first homework is really to translate these math expressions into programming. So when we see 11.5 raised to the 2, that means I know I need to use a caret. A caret needs to be exponent. This multiplication, I need to make sure that I'm going to use the asterisk. Anytime you do multiplication, it needs to have an asterisk, regardless of what it looks like in mathematical. In math, there's lots of ways to define multiplication. You can use this x here, you can use parentheses, you can just write two things next to each other like x, y. That's not the case in programming. You always need to use the asterisk. A plus sign, you just use plus, not an issue. This here, this fun root, is a square root. As you guys know, we don't have a square root key. We need to use the square root function. So we can use the built-in MATLAB function. For this one, it's not just a square root, it's a cubed root. So that means we're going to use nth root. And there's a couple ways we can calculate that as well. Same idea here, I need to use a caret. E, this is 2.7 ... raised to the negative 3.3. That's not how we write it in code though. We want to use the exp function. So when you're writing these expressions, you need to figure out, okay, that's what it looks like on paper. I need to translate what it looks like in code. So let me go back to MATLAB. Wrong one. No, that's the right one, and you guys can't see both at the same time. That's fine, but just go with me. Okay, so A equals, that's my variable, 11.5 raised to the 2 times, there's my asterisk, 1.342 plus, and then I've got my fraction. So SQRT at the top. It's 1503 divided by 13. So it's very similar to the way you might type it in your calculator. And then divided by nth root. Then I just type in negative 57 plus 12.35 raised to the 0.7, comma 3. Minus 12.5 raised to the 7 divided by 4 plus exp negative 3.3. Okay, so there's a couple things I want to point out when typing this. So one thing I want to point out is square root and nth root are both MATLAB functions. They're built-in MATLAB functions. Anytime you are using a function, regardless of who writes it, you type the name of the function, followed by open close parentheses. And then you send it the information you want to calculate. So for square root, it requires one piece of information, whatever goes under the radical. 1503 divided by 13. For nth root, it requires two pieces of information. So it requires what goes under the radical, and then what your root is. So cube root, fourth root, whatever. Okay? So you type whatever is under the radical, followed by a comma, and then send it your second piece of information. Some functions take one piece of information, some functions take two, some three, some four, etc. Most of your math functions take one piece of information. Nth root is one of those exceptions where it takes in two pieces because it needs to know what that root is, what kind of root. Also keep in mind, order of operations matters. It follows your standard order of operations for math. So it's going to do parentheses first, then exponents, then multiplication and division have equal precedence, and then addition and subtraction. You are not going to be penalized for extra parentheses. I'm getting to your question, Wilcox. Okay. So note here, I put a parentheses around the 7 divided by 4. If I didn't have that, it would do this first and then divide that answer by 4. Okay? But I don't want it to do that. I want it to raise it to 7 divided by 4 total. So I'm just going to put my parentheses around there. Another thing someone mentioned is there's lots of ways you can type this. Like this is one way to type this expression. You could, instead of using nth root, you could type this instead. You could raise it everything to the 1/3. That is also completely valid. Okay, I want you guys to have practice using the nth root function, but this is completely valid. Same thing here. You could technically just raise it to the 1/2. So you have the freedom. You have the freedom to do the calculation the way that you want it to. But this is essentially the programming way. Okay. EXP, you could also do it this way, EXP to the 1 raised to the negative 3.3. I would say this is a very poor way to do it, but it also is completely valid. So there's typically, in code, there are typically and frequently more than one way to do things. There's not just one way you have to do this calculation. Non-programming way. So this is also completely valid. Okay, so when you type this, and it gets too long, there's a couple things you could do. If you could break it up into smaller pieces. You can also do ... and then continue on the next line. So this is another way to shorten your long expressions. So we wrote something. Let's go ahead and run it. See what happens. So notice when I ran my code, I have an error. It says invalid expression. When calling a function or indexing a variable, use parentheses, otherwise check for mismatched delimiters. That means I am missing parentheses somewhere. So let me go and find them. Let me go back. Sorry, a little too overzealous. Yeah, we're good. So I ran it. So somewhere I had mismatched parentheses. Schnatuba, yeah, that's completely fine. That's exactly a way that you can add more comments. So notice what I did is I did my calculation. I ran my code. It printed out my answer in my command window. There's a couple ways that you guys can get your results. So one way is all of your variables and all their values show up in the workspace. So I can see here that now there's a variable A and it stores 91.5221. Another thing I can do is notice MATLAB is telling me that there's something here that I might want to address. And it says terminate statement with semicolon to suppress the output. I did not put a semicolon there. That means that the value of A and the result of this expression is going to be printed out to my command window. If I do not want that there, I just put a semicolon in, rerun it. Now it still shows up in my workspace, so I can still always check in my answer with my workspace, but it's not going to print out my answer in the command window. Okay. That's our first expression. Let's go ahead and look at another one. So here we have another one. Let me talk about B, and then let's go to D. Okay, so in B, same thing. You need to make sure that you are translating your mathematical expressions into programming. So I'm going to need to put parentheses here to make sure they're nicely grouped together. This 4th root, I can use raised to the 1/4, or I can just use nth root again. For this log, the log in math is log 10. So instead of just saying log, I would say log 10. The log function in MATLAB is the natural log in math. So make sure you guys keep track of what math function translates to what MATLAB function. So the log math function is the log 10 MATLAB function. You do not need to comment every line. Comments add context. Not every single line needs context. But if you want to, that's fine. So this would be log 10. This here would be my log function. And this would be parentheses. Another thing to note is to do 6.87 times 10 to the fourth, there's a couple ways you could do that. You could do 6.87 asterisk 10 raised to the fourth. You could also do 6.87 capital E 4 or 6.87 lowercase e 4. All of these are completely valid ways to do this calculation here. It is completely up to you. DM kata, in general, use the semicolon. That's going to be my default response. Always use it. You will get more practice on when you might need it versus when you don't need it. You might not use it as you're debugging and going along. I will show an example of that when we get to problem 2. But in general, get in the habit of putting a semicolon at the end of most lines of code. Okay, so like I said, those are some notes for B. Let's go ahead and talk about D. I just want to go through D. So D uses your trig functions. So you've got two sets of trig functions. You have your standard, sine, cosine, tangent, etc. You also have a second set, sine D, cos D, and tan D, to use in case your expression or your argument is in degrees. So these are the ones you're going to use if what's in parentheses is in degrees. This is what you would use if it's in radians. So as I'm going through this D calculation, keep in mind this would be tan, this would be cos D, because this is degrees. This here would be sine D, this would be cos. So let's go ahead and calculate this one. Sorry, once again, you guys can't see it, but just trust me. So for D, I have tan of pi over 3. Remember, I can just use pi. It's a built-in MATLAB variable. Times cos D of 15. And then I need to close my parentheses. And all of this is raised to the 2/3. Once again, keeping track of the fact that I have parentheses around 2/3. Plus, I have sine D 45. That whole thing squared. So this is sine squared 45. Typically we say it as sine squared 45 to differentiate between sine of 45 squared. You can't do this in MATLAB. In MATLAB, this is not valid. Sine D is a function. Remember, when we use a function, we type the name immediately followed by open close parentheses. So the squared goes at the end. Put a semicolon, okay? Just put semicolons. Semicolons everywhere. Divided by cos of pi over 6, the quantity cubed. So this is what this one might look like. But let's say I didn't do this. Notice, if I forget parentheses or something, my code still runs. So it tells me that D equals 1.7028. So when you guys are writing your code, start in MATLAB, type it up, see what you get. Make sure there's no errors. And make sure that when you press run, there's no errors. Then what you guys should do is go over to MATLAB Grader, which, like I said, you guys all should have access to. And homework 1, problem 2, you should see that. There's going to be an area where you can copy and paste your code in. So you go to MATLAB, copy this in, paste, and then you can run your script. Once again, that's just like when you press run in MATLAB. You'll see what's printed out, but you really want to press submit. Submit will tell you a couple things. It will tell you if your variables are named correctly, and it will tell you if they have the correct values. So here I calculated A. I have a variable named A, that's great, and it stores the right value. Awesome. Variable B doesn't exist, that's fine. Variable D, Notice it just says variable d has an incorrect value. So that means somewhere in my calculation, I calculated d incorrectly. And I know it's because I forgot my parentheses here. It was taking this, squaring it, and dividing that answer by 3 instead of raising it to the 2/3. So I change it, submit it, and now I can see that D is now correct. Okay, so make sure that if you change any code in here, you copy and paste it back into MATLAB. There you go. That's essentially how you would do that first set of problems, or that first problem, those 4 calculations. Okay, let's get to problem 2. So, once again, just like we did for problem 1, we're going to create a new script file, put those comments at the top. You can copy and paste things over and just change what you need to change. I do that all of the time. It's a really great tip. So copy, paste that over. Now I'm going to, instead of calculating mathematical expressions, for this problem, for problem 2, you're going to be verifying trig identities. Okay, so I go over to my document. Like I said, this is a different problem than yours, but it's very similar. So I'm gonna focus on, let's do the second one. Pretend that one's not there. Let's do the second one. So here it says, verify the following trig identity by evaluating the left-hand side and the right-hand side independently. Okay, so this tells me that the arc cosine of x minus the arc cosine of y equals the arc sine of this big expression, and I have to use it for these two values, for x equals 1 divided by the square root of 2, and y equals the square root of 3 over 2. So once again, I have a bunch of these, I have a mathematical expression I need to translate into MATLAB. So Pat Fallon, good question. In your document, it says use P1A and P1B. I was using a different problem that was not for your homework 1, because your homework 1 wasn't that problem. So make sure it's the variables that are listed in the document. It's a good question. So you need P1A and P1B. So notice for arc cosine, arc sine, those math functions, I'm going to use a sine or a sine d, and then a cosine or a cos d. I would use the d if I have degrees. In this instance, they're not in degrees, so I'm assuming they're radians. For your homework document, assume it's radians as well. So for your homework document, for part B, or for problem 2, not part B, for problem 2, it's all radians. Okay, keep that in mind. Okay, so let's go ahead and just a couple things to note. Note I need asterisk here, I need square root function here, asterisk here, caret, and I think that's it. Okay, so let's go ahead and write the code for this. So first things first, I'm going to type x at the top. X is 1 over the square root of 2. And then y is square root of 3 divided by 2. I put semicolons after both of these lines of code because even for debugging, I don't really need to know what those values are. Those values really aren't that important. What's important are my calculations later on. Okay, so now I'm going to calculate the left-hand side, calculate the right-hand side, and then check to see what that difference is. So left-hand side, this is for problem 2 or B, whatever it is. I'm going to use my a cos function, because that's what I'm doing. I'm calculating the arc cosine of x. So a cos is a MATLAB function. I'm sending it the value of x minus a cos y. There we go, that's my left-hand side. Do the same thing for my right-hand side. Now I'm using the a sine function, and then it's x times y minus the square root of 1 minus x squared times 1 minus y squared. Note, you don't need all of these spaces. These spaces, they just help clarify code. Like I have an empty line here, even though it's not really a line of code, I have an empty line here, just because it helps separate things. A Lombard 8 mentions, can we define variables in the comment? And then, so you really want to get in the habit of storing your values in variables and using those variables in expressions. You don't want to say a cosine of 1 divided by the square root of 2. That is poor programming practice, and it's really going to make for longer coding, longer to write your code, longer to debug your code. So you really want to get in the practice of storing your values in variables and using those variables in your expressions. I hope that was what you were asking. So I wrote some code. I'm going to go ahead and save this file. I should have saved this to begin with. Note, I need to save it according to how the document mentions. Homework 1, problem 2, underscore u by t name dot m. So now it's saved. A Lombard, you're not going to be docked points for this homework. Like I said, that's not necessarily incorrect. It's just poor programming practice, and it's going to make for harder to write, harder to debug in the future. Okay, so just make sure you're moving forward. Now that you know, moving forward, making those changes. Okay, so I saved my code. I wrote my code. Let me go ahead and run my code. Notice when I run, I get some errors. It says, one thing to note is this is a hyperlink. This here, this underline, it's a hyperlink. It will take you mostly to where the error is. It's not always 100% correct, but it will tell you mostly, hey, there's an error here. So notice my cursor showed up here, and I'm missing my asterisk. So even though in the document it's written as just parentheses, parentheses, programming, you need to still use the asterisk for multiplication. Anytime you make a change, save it, rerun it, and there are no errors. Notice nothing was printed out in the command window because everything has a semicolon. And if I look in my workspace, I can see that both of these values are 0.2618, left-hand side and right-hand side. That's a pretty good indicator that I got it right. If you want to see things out to more decimal places, take the semicolon off and run again. By default, your command window will only print out 4 digits past the decimal point as well. If you want to change that, we can use something called format. So format short, if I type format short, the default, or that will ensure I have 4 digits past the decimal point. If I want to change that, I can do format long. Format long is going to print out 16 digits past the decimal point. And we can see here that with more precision printed out, that I have, these are still pretty much the same number, which is what I would expect. There are a couple other things you can change with format. Notice it prints out a whole bunch of white spaces in between things. If you want to get rid of those white spaces, you can say format compact. So now when you run it and it prints out, it's nicely packaged. That is one of my favorite things. You can do scientific notation by saying format short or long E. That will do scientific notation. I'm not a big fan of scientific notation, so I'm going to go back to format long. Okay. The last thing to do for this homework, or for this one, is to calculate the absolute difference. So ABS equals, I'm going to use the absolute value function. And then I'm going to take my left-hand side, it doesn't matter which one you choose, minus your right-hand side. So now when I run, I can see that this number, they're practically the same, and I can confirm that by seeing that my absolute difference between them is on the scale of 10 to the negative 16. that's a pretty small number. I think they're practically the same. So you might want to take off the semicolon if you're trying to debug and trying to work through some stuff by needing the command window. In general, though, it's really good practice to put on the semicolon. For these first couple of homeworks, it's not going to be that big of a deal. When you get to more complicated code, if you leave the semicolon off and it keeps printing out in the command window, it will significantly slow down executing your code. So it's good practice to start now to put semicolons in pretty much after most lines. Yes, debugging is a word for fixing errors. It comes from when programming first started, you had punch cards for computers. Like you would literally punch cards and put it in the computer and it would do what the punch card mentioned. And like sometimes you would literally find bugs on the punch cards that were causing errors. So that's where it comes from. It's called debugging. Getting rid of all the errors. What does it say in front of LHS? Nothing. ABS, right here. ABS. ABS is a function in MATLAB that calculates the absolute value. Sorry if that was loud. Okay, let me go over a couple key things with this problem that I didn't get to in the videos. So I went over this top part in the videos briefly, what is a script file, but I didn't go over this second piece where it talks about how code in a script file is executed sequentially. That means it starts at the top, executes every single line of code, and then from left to right. So essentially the way we read English. A couple things to note about this before we demonstrate this in the program is any text following a comment symbol is ignored. So we know that comments are ignored. If you look at the document or the program I have here, along the side, you'll see line numbers. And next to those line numbers, you'll see dashes next to some of the lines. The ones that don't have dashes are comment-only lines or blank spaces. So here in these 10 lines, I only have 1, 2, 3, 4, 5 really lines of code. Okay, so anything that is a comment line is completely ignored. Anything that's a blank line is completely ignored. But comment lines and blank lines are highly used to organize our code and make it easier to read. So use them. And then we've got this idea of the search path. So the search path is something that MATLAB uses in order to identify what to do when it runs into something that's not a number. So if you remember, computers do calculations on numbers. That's what they do at their core. They take numbers, they combine them according to operators. So when we run into something that's non-numerical or not an operator, MATLAB is going to follow these 4 steps in order to figure out what that means. So the first thing it does is it checks to see if it's a variable. So it goes to your workspace and checks to see, hey, is this a variable? Should I use a number here? If it's not a variable, then it's going to go to your command window or your current folder, and check to see if it's a script file that exists in your current folder. If it's not there, then it can see if it's a script file somewhere else on the search path. And then if it's not there, it's going to check to see if it's a built-in MATLAB function. So we've learned about several different mathematical functions already. So these are the 4 steps it is going to jump through in order to figure out what to do when it runs into something that's not a number or not an operator. So if we look back at our code, let me clear my workspace and clear my command window. So I'm going to put a breakpoint here. When I do that, just by clicking on that line, when I do that, it opens up this specific MATLAB debugger. It's a tool inside of MATLAB that we can use to run our code line by line. You don't need to use it. I will illustrate it in class though. Okay, so note I'm here. That means I've skipped over lines 1, 2, 3, 4 because there's no code there. So I've hit line 5. When I execute line 5, on the left-hand side, I have X. X is going to be a variable. It's going to it's going to set aside a container to store X. whatever goes inside of X. What it's going to store inside of X is whatever shows up on the right-hand side. So on the right-hand side, I have 1 divided by, and notice I have SQRT. This is not a number. This is words. This is letters. So what MATLAB is going to do is it's going to check to see, is it a variable in my workspace? If I go down here, there's no variable named SQRT. It's not there. Then it's going to check to see if it is a script file or function file in my current folder. There's no file in here called SQRT. It's going to check other places to see if it's a file there. If it's not, it's going to check to see if it's a built-in MATLAB function, which it is. We know that. We were told SQRT is a built-in MATLAB function. So what it's going to do is it's going to send that to that function, do the calculations, and then give me back the answer and calculate this expression. That's all to execute this one line of code. Obviously, it does a little faster. Then it executes this line of code. So y equals same thing. So it runs into some non-numerical text. SQRT. It's not a variable. It's not a script file or a function file here. It's not elsewhere. It's a built-in MATLAB function. It does that calculation. Then it hits this line of code. Here is a variable. It's going to create this variable. It's going to set aside some space in memory and name it LHS. It's going to have that container. It's going to store whatever this ends up being. ACOS, non-numerical. It's not a variable. It's not in my current folder. It's not elsewhere. It's a built-in MATLAB function. Then I hit X. X, non-numerical. It's going to check my workspace. Oh, hey! It's a value. So it's going to replace X with that value. 0.7071. Obviously, it's going to have more digits, but essentially it's replacing that X with whatever was in my workspace. Minus a cosine, same thing, it's a built-in MATLAB function. Y checks to see if it's a variable. It is. It's a 0.8660. So essentially it replaces X and Y with what those values are. It does it behind the scenes, so I'm just saying that's what's happening behind the scenes. Same thing when it gets to this line of code. So it replaces X with whatever the current value is, replaces Y with the current value. Same thing here, same thing here. Asine, SQRT are built-in MATLAB functions. When I get to ABS, when I get to this line, ABS is a built-in MATLAB function. LHSB, it uses this value that was calculated here. RHSB, it uses the value that was calculated here. And then it's done. So keep in mind that if I had rearranged my code, if I had typed ABS first, and then I ran my code. So first it's going to calculate line 5. Then it's going to calculate line 6. By the time I get to line 8, it's going to go through the same steps. Note, it's going to set aside some space, name a variable ABS. ABS here, it's not a variable, or it's not a variable, it's not a function or script file. In my command window, it's not elsewhere, it's a built-in MATLAB function. Then I get to LHSB. LHSB is not a variable that shows up in my workspace yet. It's not in my current folder. It's not elsewhere. It's not a built-in MATLAB function. So I'm going to run into an error where it says unrecognized function or variable LHSB. If you run into this error, that means that either you spelled something wrong or you made the mistake of using your variables before you created them. So what that means is you need to make sure your variables show up on the left-hand side before they show up on the right-hand side. They need to show up in your workspace before they are used. Okay. We've got 5 minutes left of class, I think. Some final notes in terms of best practices. Make sure you're using a semicolon. We already mentioned that. Also, you want to make sure that you're not naming your variables the same as any built-in MATLAB functions. So I really don't want to name a variable acos equals 12 before I use it. I will run into this situation where you don't know what this means yet. But it's using, when it runs into this word acos, it sees it's a variable first, so it's trying to use this value of 12 versus using the built-in MATLAB function. Dr. Ali mentions if you just name your variables all capital letters, then you won't really run into an issue, but I'm leaving it up to you. So, Benny, going things over in your current folder. So your current folder, it's just your files. So if I open up my file explorer, do you have a Mac or a Windows? Because I know it's different. People have a different relationship with their file structure depending on whether or not they have a Mac or a Windows. But if you look at this file structure here versus this one here, it's exactly the same. Okay, so PC. So it matches what I am showing you. So in Documents, I created this folder called EAS 230. In MATLAB, I just navigated to that. So all of my files show up. Like here's my C drive. Click through Users, click through Emily Hammond, click through Documents, click through EAS 230. So it behaves exactly the way that you would navigate through folders using your Windows Explorer. Like if I change something in here, like let's say, let me close that out. Let's say I want to copy and paste this folder, or this file. Like it will copy and paste it out of here as well. And now it shows up here. If I want to copy and paste this in, I can just drag it into that folder. Now it shows up in this folder. So if you have files that exist somewhere else, just copy and paste them into whatever folder you want. I could also copy and paste it into here directly. You should still be able to access OneDrive. Yeah, you should still be, if you have OneDrive synced on your desktop, like here's OneDrive, you should be able to, yeah, like here I can just go to OneDrive. Okay, so, AP Cruzy, thank you for reminding me. If you are using MATLAB Online, that's not MATLAB Online. If you are using MATLAB Online, you essentially go through the same steps. There's a couple caveats. So your current folder still shows up. You'll still create a new script. You'll still save it the same. You'll still save it in your MATLAB drive. It just will save in your MATLAB drive instead. You still type everything in. Just if you want your files to come off of MATLAB Online, you would just click on it, go to Home, and click Download. Let me go over how to submit your homework files first, and then I will keep answering questions. Okay, so let me go through it on MATLAB Grader, or MATLAB Online. Come on. Sometimes MATLAB Online is very glitchy, like right now. New script. Okay. If it's ever too glitchy for MATLAB Online, just refresh the page. It should save everything. New. There we go. There we go. Let's say you did everything on MATLAB Online, you ran it, you see everything that shows up in your command window. Keep in mind, if you make a change and you press run, in MATLAB, typically in MATLAB Online, it will not automatically save. It will automatically save from MATLAB in general. Okay, so just if it ever asks you to resave something, just cancel it. And like here, it didn't save it first, just cancel, save it, and then rerun it. Okay, so let's say you want to submit your files. If you are in MATLAB Online, you would just highlight the file, click download, highlight the other file, click download. So now they will show up in your downloads. If you are on normal MATLAB, you don't have to worry about that. Then what you're gonna do is you're gonna go over to where homework 1 is, click this link here. You can browse your local files, go to where they're saved, and attach both of them to the same submission. Both of them to the same submission. Then you click submit, and then you're done. And that's how you would submit your files. Obviously for you guys, it would show up as green. It doesn't show up for me because I'm not in student preview. You can always go back to see what you submitted. So if you just go back and click that again, it will show you your submission. You can download the files you submitted, test them, etc. Okay, so let me finish up with some questions. What is the ASV file? So yes, Sophia noticed this ASV. It's just a temporary file. Like when you open up a Word document, it has a temp file that shows up. Same thing with MATLAB, shows up as the ASV. If I close out of these files, it will go away. See, it goes away. If I reopen it and rerun it, it will come back. Okay, it's just a temporary file. How do you raise a trig function to a power? Just like this. So when we say sine squared of x, what we're really saying is sine of x squared. So this is math notation. This is what we need to use in MATLAB. Kind of like when you're taking derivatives. Those are fun, right? You need to do this when you're doing derivatives. You bring the 2 down in front. Anyway, we're not doing derivatives right now. We're doing MATLAB. Okay, so this is the notation you need to use when you're thinking about raising something to a power. I can't get the code to save directly to one. Ooh. Pat Fallon, I don't know. I don't work directly with OneDrive. I save everything on Box. There might be some issues with the way that OneDrive links to your file system. I would try to Google that. If you are still running into issues, I would talk to UBIT. Why does it say multiplication? So Cupcake Panda, talking about for this one. So this wasn't for your homework. This is a completely different problem. This was this problem here, where I'm talking about the arc sine, which means I use the a sine function. If it's just sine, you would use the sine function. So make sure you're working with the functions you need to work with for the specific problem. I used a sine here because that was the math expression I was trying to write. To confirm what okay, class is technically over. You guys are free to leave. I will stick around for a little bit to answer some questions. So yes, so hopefully I answered a lot of your questions. Make sure you guys go back to MATLAB Grader. If you've already submitted to MATLAB Grader and you got the wrong answers, go back and resubmit to MATLAB Grader. We found some errors in office hours today. So if all of your answers in MATLAB Grader are correct, that should, as long as you submit it properly, then you should get a 100% when you grade it. That's not always going to be the case in the future, but for this one, yes, absolutely. Yes, so in the homework, it says all answers are to be displayed in the command window. Don't worry about that. I know it says that in the homework, but get in practice of, that's Dr. Ali's preference, and we use the same homework documents. So just, your points are not going to be taken off if you do not use a semicolon, but just get in that practice. It will be very useful in the future if you are in that habit of making sure you use a semicolon. Okay. You shouldn't be getting imaginary answers for your homework. I mean, I'm not going to do office hours right now. There are office hours again at 1, but if you're getting imaginary numbers, that probably indicates that you are using the wrong function. Like you might be using sine instead of sine d. Okay, any final questions in terms of content today? Final questions? I mean, keep in mind when you have an argument that's in degrees, you need to use sine d or cos d or tan d. So when you're looking at the homework, if it's in radians, you're using the normal trig functions. If you have something in degrees, you're using with the d at the end. Shnatuba, okay, so comments, you're not going to be graded on your comments right now for your homeworks. You will be graded on your comments for your programming project. It's really just good practice to put in comments. Therefore, we know what you're talking about. You know what you're talking about. These are going to be references for later on as well. So you're not going to be graded for right or wrong comments, but they are best practices to use and just get in the habit of it so that when you get to the project, it's easier. You cannot print out the homework. You can't download it. It's only accessible on Box, unfortunately. We're just trying to limit Chegg issues. So it's watermarked and you can't download it. Sorry. Okay, I will see. Oh, I know, that is very handy. Sorry. Okay, I'll see you guys all on Wednesday.